Welcome to Every Animal Has an Owner, a mostly large animal podcast for veterinarians and the people that depend on them.
I'm Paul Hauer. I'm a veterinarian, and I currently work for a consultant group called Edge Consulting. Prior to that, I graduated from vet school in 1984. I was a mixed animal practitioner for a while, joined the USDA, and went to the Center for Veterinary Biologics in 1990, and I spent 25 years in the Center for Veterinary Biologics, which is the entity in the USDA that regulates veterinary vaccines. New technologies have been coming along that make vaccine manufacturing a little more efficient and a little more pinpointed so that you don't have to give whole cell virus or bacterial vaccines. One of those methods is by expressing the protein in an expression system, such as baculovirus expression. And what you do then is you make a lot of just the proteins that are important for the immune response to recognize. So a baculovirus expression system can make, for instance, the surface protein on a virus that is responsible for binding cells in a human or animal. And by doing that, you can focus an immune response when you give a subunit vaccine so that those proteins are blocked and you get immunity that way. Now, there's another method of vaccine manufacturing, and that's using messenger RNA or mRNA vaccines. Now, you take messenger RNA, which is a substance that codes from DNA in an organism, and it then translates into protein. When you take the messenger RNA, you can put it into a lipid particle, or you can put it in a viral shell and give it to an animal. It then goes into the cell of the animal, it uncoats, and it uses the machinery in the cell to produce the protein that is foreign and then is recognized by the immune system. So in one method, the subunit expressed protein, there you have control outside of the animal. You can make the protein, you can batch it, you can combine it with others. But with the mRNA technology, you put the control of the manufacture of that protein into the animal's cell, and it makes the protein internally. Now, they both have advantages and disadvantages, but that's the basic technology. They are different. mRNA vaccines and subunit vaccines are different. So both subunit vaccines, which express protein outside in an expression system, or mRNA vaccines, which put little pieces of mRNA into the body of an animal and they make the protein. Both of those can be what are called platform vaccines and can respond very quickly to emerging diseases or mutating diseases. Platform vaccines are ones where you have a very rigid and well-documented production parameters, and then you just swap out the protein. In the case of subunit vaccines, the protein can be swapped out, or in the case of mRNA vaccines, the mRNA that codes for the protein that you're targeting. You can put multiple proteins into a vaccine that's subunit. You can manufacture the proteins externally and mix them in any level that you want to make sure that you get the immune reaction that you want to each protein. That's a little more difficult with mRNA vaccines because you give up control over the production process, right? You're putting mRNA into the animal and their cells are manufacturing it. And it's pretty difficult to know how a body will react to different mixtures of mRNA. So that's one thing that subunit has as an advantage in that you can stack multiple antigens easier and have more of a known outcome than in subunit vaccines than you can in mRNA vaccines. Now, you still have to keep subunit vaccines, which are, protein mostly. You have to keep them refrigerated normally, but mRNA is much more unstable, and usually those vaccines have to be kept frozen right up until the time you use them.